Hello, welcome back. I would like to ask the people online if they have any questions regarding the posters. There are no questions. You can proceed with the next session. Nothing so far. Great.
Theo?
Hi, Ismail. Just a second, right?
Ah, okay. I was just wondering if you were there.
Late in the afternoon. Welcome to the organic material analysis session. I'm Angel, for those who don't know me. In this session, we have 4 presenters. I will be talking about, the first one is about animals and the other 3 about plants. The first 2 presentations are online and the other 2 are here. So the first presentation is by Ismael Rodriguez Palomo from the University of Cambridge, who will talk to us about open search proteomics for the identification of proteins and the quantification of deamidation in ceramics. All presenters have 15 minutes, and then we'll have a 20-minute Q&A session. Ismael, the floor is yours.
Yes, I'm here. Should I share my slides now?
Yes, please.
And share my screen? Yes.
Looks good.
Looks good? Okay. Yeah. All right. So I will start if that's okay with everyone, if you're already there. Hello, everyone. My name is Ismael Rodriguez, as you've already heard. And my presentation is going to be about the use of protein analysis in ceramics. And I'm going to talk about new methods called open search proteomics to improve the identification of proteins and their modifications in ceramics. So first of all, residue analysis of contents in ceramics gives us insights into past food preparation and consumption practices, transport of goods, trade, management, and in particular, the study of proteins is compared to, for example, lipid analysis. The study of proteins is species and tissue specific, and it allows discriminating between, for example, the presence of either milk, meat, or cheese, even if it's from the same species, and it can also identify whether there was a However, the study of proteins in general, and in particular in ceramics, requires certain precautions and procedures when the sample is prepared and proteins extracted in order to minimize the contamination and maximize the protein yield. For example, in the excavation, samples need to be stored in aluminum foil, should not be washed, and should be the handling of the samples and of the ceramics should be minimized. And then in the lab, we also need clean and dedicated rooms, clean equipment, chemicals that are just used for this and not shared between different procedures. Once we have this ready, we can go to the sampling. Proteins can be extracted directly from something as small as less than 1 gram of ground ceramic matrix, or also from scrapes from different areas on the surface of the ceramic, or even from calcareous incrustations that sometimes have proteins inside them. Finally, the final steps. For the final step, we need to further concentrate and purify the proteins using some standard protocols. Once we have our protein of pool or mixture of proteins, we go to an enzyme digestion that will break the proteins into peptides, and we know exactly where these enzymes will cut the proteins. This, again, mixture of peptides, we're going to introduce them into the liquid chromatography, which is the first part of the whole analytical technique. This will separate the peptides by elution time, and we will then have our first round of mass spectrometry that generates what we call MS1 spectrum. So we have each peak here will be one peptide, and we will separate them by masses. But this is not enough, just the mass is not enough to identify a peptide, because a lot different peptides with different sequences can have the same mass or almost the same mass. So we need a second round of mass spectrometry. So we're going to pick every peptide, every peak one by one. We're going to fragment it, and we're going to generate this MS2 spectrum of the fragments of a single peptide. And we do this by colliding the peptides with a neutral gas. Now, using a database of known protein sequences and some specialized software, we can analyze this spectrum and match which MS2 spectrum correspond to which peptide. But how does this work? This is where I will focus in this presentation. So first we start with our observed MS2 spectrum and the known proteins. To these proteins, we're gonna digest them in silico, the same way the actual proteins were digested in the lab, generating a set of theoretical peptides, of which we can derive theoretical spectrum. Now, what we call a search engine is going to try to match all the MS2 spectra that we obtain from the mass spectrometer with the theoretical spectrum, in a way like you can see here, and then matches that fulfill certain requirements are what we call peptide spectrum matches, or PSMs. So now we know, for example, that in this case, in our ceramic sample, we have this peptide that belongs to a sheep milk protein. So then we can start answering the questions that I mentioned in the beginning. And then, of course, the more peptides that we can attribute uniquely to the same protein, the higher the certainty. However, there's another layer of complexity in this, is that proteins can have post-translational modifications, or PTMs, meaning that there are modifications that occurred after the protein was synthesized in the cells. It can happen either in vivo in the organism because it has some functionality, but it can also be post-mortem, post-deposition, or it can also happen as lab artifacts because of the protocols to extract them. We can also add this modification to the proteins. So for example, a protein, as you can see here, can have a sugar molecule, and this produces a shift in the MS2 spectra that we need to consider if we want to, at some point, identify this spectra here as a peptide that belongs to this whole protein. So we need to take into account these possible modifications. However, there's many challenges in general for paleoproteomics that in particular for the study of protein in ceramics, some of them are even more acute. For example, because the peptide spectrum matches are never perfect, also some peptides cannot be uniquely assigned to proteins. We have to deal with uncertainties, and we have to be able to measure these uncertainties in the identifications, and moreover, we can also have misidentifications. Also, the choice of the sequences that we have in the database can bias the analysis because some species are better characterized than others. Finally, we can also have, of course, contamination with exogenous modern materials that can in the end bias our conclusions of what was contained in a given vessel, for example. And in general, the yield of proteins that we can, the yield of destruction is usually very low. We don't obtain high amounts of proteins. It can be enough for some analysis, but maybe for some others, it's not enough. And finally, and this is where I will focus in this specific problem, is that only 5 to 10% of the spectra, which they're already not enough because we're not extracting enough too many proteins, but only 5 or 10% of the spectra are identified. So what is the rest of these spectra that we cannot identify? We don't know for sure because we are not identifying them, but we think that we might be missing peptides that have some modifications, as I said before, that we were not accounting for. Because we're not accounting these possible modifications, in the end, we cannot identify these peptides that have them. So this is the problem usually for what is called a closed search strategy, which is the more widely used in paleoproteomics, in the study of ancient proteins. So what we have is that we need to specify from the beginning which modifications we want to look for. We're going to add them like in silico in the computer to the peptides, and we're going to generate theoretical spectra, which is gonna increase the search space, which is a problem. And then in the end, we're going to try to match the observed spectra with the theoretical spectra. In contrast to this strategy, we have what we call an open search. Here we don't say anything about PTMs to start with, and we move straight into trying to match the theoretical spectra and the spectra that we got from our sample. However, what we do is that we're going to tolerate large mass shifts in the peptide spectrum matches, which is something we were not doing before. And this is why we're calling this strategy open. And before, because we were not tolerating these large shifts, we're calling it a closed search. So we're going to allow, as I said, we're going to allow these large mass shifts. We're going to have our peptide spectrum matches. And then these shifts, we're gonna, which is a number now, we're gonna go to a repository of known post-translational modifications, and we're gonna try to see to which modification these shifts corresponds to. The advantages of this is that we don't need any previous knowledge about which modifications can happen or not. We are not increasing the search space as we were doing before. And we have the ability of discovering new modifications that some proteins can have that we were not aware of. And this is where we think the open search can increase the identification of peptides. So I sort of wanted to benchmark this open search method on ceramic samples. So this is what I did. I went and revisited some proteomics analysis on ceramics. Actually, some of the very few that actually succeeded. So the raw data is deposited on a dedicated repository for proteomics, which is called PRIDE. And they are all from the Mediterranean and Middle Eastern region. The oldest samples are as old as 8,000 years old. And in total, we have 48 samples. Some of them come from extractions directly from the ceramic matrix itself, but some others are also from calcified deposits. And the software that I use, we have, first of all, one called MS Fragger, which is capable of doing closed and open search. And we have also AlphaPep, which is also capable of doing closed and open search. And to compare this, we have MaxQuant, which is one of the most widely used software for proteomics, and especially for paleoproteomics. And it's usually used in a closed search framework. So I did this comparison between sort of these two with MaxQuant and also between closed and open search. So to measure the performance of each software, I calculated the fraction of spectra that was identified. And these results indicate that in general, MS Fragger and AlphaPep perform better than MaxQuant, but also that they also show that the search, open search outperformed the closed search, both in MS Fragger and AlphaPep. The open search in MS Fragger outperformed the rest, even the one in AlphaPep, and this is because it has some other specific tools and methods that can deal with this type of open search. Because in AlphaPep, you just do the open search by, in general, allowing wide masked shifts. But MS Fragger is also accounting for other things that are specific to this type of search. The increase of fraction of identified spectra is not different from samples that were coming from calcareous incrustations or from the matrix. However, when we look at the absolute number of protein and peptides that we identify, always from the ceramic matrix, we identify less proteins and less peptides than from calcareous incrustations because proteins can survive there longer in this type of ceramic mineral substrate. Finally, and this is something important, I found glycations, so different types of sugars added to proteins in the open search strategy, which indicates, which is giving me a hint of why these open search methods are outperforming the rest, and it's because of these modifications that before I could not account for, but now I'm finding. There are some further advantages of this software. One of them is that it is fully free and open source, and this allows for the community to interact and create new tools because they're also very modular. And then they also run much faster than MaxQuant, going from days to hours. As future work, I will have to investigate what these modifications are and what they can tell us. Also expand the database and see that we use and see if I can identify different species, different foodstuffs. And then I would also need to further optimize the workflows and parameters. And finally, I would like to highlight the importance of publishing the raw data and results in standard formats and open repositories, which allows reanalysis with newer tools without having to resamples. So I could only do this study because the authors of some previous work took the time to upload their data. So this is all. Thank you so much for listening, and especially thank you for the organizers of this conference. Thank you.
Thank you very much, Ismael. Thank you for sticking to the time and the interesting things you talked to us about. We'll have a question session in the end.
Yes.
So now we will continue with the second online presentation. Will be by Maria Usu, who is a postdoctoral researcher at the Museum of Natural History in Paris and CNRS. And she will talk to us about the use of fruit trees during the pre-pottery Neolithic cycles, the correlation of their botanical and ethnobotanical date. Maria, you there?
Yes, hello, can you see my screen?
Yes,
Okay.
it looks great. You can start whenever you're ready.
Okay, all right. So hello, everyone. Thank you very much for organizing this conference. So now I will talk about plants and the use of fruit trees in pre-pottery Neolithic Cyprus. This is a part of the results of my PhD research conducted in collaboration between the National Natural History Museum in Paris and the University of Cyprus. Oh, it's not moving. So field archaeological research during the last 20 to 30 years in Cyprus has revealed new information about the earliest phase of pre-pottery Neolithic on the island, with the discovery of new archaeological sites such as Klimonas, Shilurogamos, Programnos, and Milouthia. This research has revealed also information about the introduction of animal and plants from the continent and the exploitation of these resources by the inhabitants of the site. In this presentation, we'll focus on 3 sites located near the south coast of Cyprus: Agios Tichonas Klimonas, Paraklisos Shilurogamos, and Chirokidea Vouni. These 3 sites let us have a vision on the long durée of the pre-pottery Neolithic in Cyprus. And the results presented here come from the anthropological analysis, that is the analysis of wood charcoal recovered at the site, and the seeds and fruit remains analysis, in order to understand the exploitation of fruit trees, their role and use in everyday life in Cyprus. More than 11,000 anthropological remains have been studied during my PhD, and more than 6,000 seed and fruit remains have been studied that show the exploitation of a large variety of woody taxa. Among them, wild pistachios is the most important resource that seems to be exploited during this period. They are dominant at the 3 sites, both in terms of anthropological and fruit remains. According to an identification key developed during my research, applying diagnostic criteria for the identification of fruit remains, let us see that 3 species are present in the assemblages: Atlas pistachio, terebinth pistachio, and lentis pistachio. And 3 of them, all of them, are indigenous to the flora of Cyprus. According to charcoal remains, these taxa have also been identified. Fig and olives are other 2 taxa recovered at the site. At Klimonas, we have the earliest evidence of fig fruit recovered in archaeological context. It's one indigenous taxon plant in Cyprus, as this is demonstrated also by paleontological leaf imprints found in the region of Kerinia. On the other hand, olive is also identified by charcoal and fruit remains, and most probably corresponds to the wild olive that is present around the sites even today. Other taxa that have been identified by the charcoal and fruit remains analysis is rock rose and Greek strawberry tree. Here you can see some photos of the fruit remains and the charcoal remains. These 2 taxa are very important still today in the Mediterranean maquis. Oak is another taxon very important, especially in the anthropological assemblages. There are 2 types identified. One is deciduous oak, and the other one is evergreen oak. And this taxon is also identified by 1 fruit remain recovered at Chirokidea. The common myrtle and chaste tree, 2 taxa that are usually found near humid localities, are also identified but only from charcoal remains. Finally, the rose family is represented by several wood and fruit remains. We have seed remains of pear and hawthorn recovered at Chirokidea, also 1 rose fruit remain, and from the earliest levels of Chirokidea onwards, we have also the presence of almond, but prunus wood charcoal is also present already at Klimonas and Shilurogambos. So how can we interpret all these results? What do they tell us in the archaeological context? First of all, what is probably most obvious, they give us information about the paleoenvironment during this period. These taxa recovered at the sites can be still found today in forest formations, in pine forests, but also in oak forests that seem to be more developed in the past. Also, they can be found in the Mediterranean maquis, one of the main vegetal formations still preserved around the sites today and all around the Mediterranean belts of Cyprus and in general in the Mediterranean. On the other hand, they can give us useful information about their uses in everyday life activities at the sites. In order to do so, we use a contextual analysis, that is, all the information about the context where these finds have been recovered, and other archaeological data coming from the study of archaeological remains such as architecture or lithic and bone tools. I would like to highlight here that the greatest part of archaeobotanical remains studied in the framework of my PhD research, they come from secondary contexts, that is pits or wells. So we don't have any destruction layers at the sites. We don't have any in situ archaeobotanical remains. All these remains come from contexts where were redeposited as rubbish or discarded from the site. For this reason, it is very important to look at the ethnobotanical data in order to use them and see what other interpretations we can address about the uses of these plant remains. Ethnobotanical data include all the traditional uses of plants by traditional human populations. So the first use of these remains, and more precisely the wood remains, they were used as fuel at the sites. Several fireplaces have been identified, recovered, and excavated at the site. And according to the analysis of charcoal remains, it seems that pistacia wood was very important for this purpose during this period. On the other hand, all these taxa presented before, they bear edible fruits that can be consumed by humans, fresh, dried, roasted, or grilled. And of course, the use of fire during the preparation of food preparations or even for roasting the fruit remains may implicate the accidental carbonization of some of these remains that are then recovered in the archaeological sites. The fruits of some of these taxa shown before can be also used for the production of flour, as it's the case still today in Algeria, and you can see a photo on the right, or they can also be used for the extraction of oil, as it's the case of Pistacia lendiscus still practiced today in Tunisia and Algeria. Wood could have been used also for construction. We don't have any direct evidence for the use of wood in architecture because they're not preserved in situ. However, we have indirect evidence, that is the numerous post and pole holes discovered at Klimonas and of course at Chilurogambos, and you can see the photos on this slide. And Hierogidea, we have some roof fragments preserved in one house that let us study the structure of the roof, and we can see that the wood was important for the construction of the roofs at Hierogidea. I would like to mention that according to ethnobotanical studies at the Zagros Mountains, it seems that they show that pistacia trees are managed in order to preserve and produce wood that is then used for architecture. At Chilurogambos, we have the preservation also of cob fragments that were accidentally burned, and they still preserve imprints of branches. And in two contexts, we have the preservation of wood charcoal in association with burned cob fragments that shows that probably Greek strawberry tree and olive were used in architecture. At Chilurogambos and Hierogidea, we can also address the hypothesis of the use of leaves as fodder for domestic animals. Of course, we're not talking about Klimonas, where the economy and subsistence strategies were based mostly only on hunting and not on animal breeding. Here you can see one photo for the collection of leafy hay still practiced in Greece during the last century. And among the taxa presented and preserved at the sites, the Greek strawberry tree, olive, wild pistachio, oak, fig, and species of the apple family can be used for this purpose. Two other everyday activities for which we do have evidence from lithic and bone tools are basketry and woodworking. Of course, we don't have any wooden objects preserved at the sites, but the use-wear analysis and show these activities were practiced at the sites in the domestic context. And of course, many of the taxa presented here can be useful for these activities, such as pistachio, the chase tree, or myrtle. And finally, some other uses, possible uses of these plants include the medicinal uses, leather tanning, the production of dyes, etc. So many of the taxa presented here produce resin in the wood that can be useful for medicinal uses. And here you can see some photos of Pistacia resin collection and Cistus resin collection. I would like to note that at Chilurogambos and at Kapandreas Kastros in the northern part of Cyprus, there are some sickle elements preserving a clue that for which, of course, we don't know yet if it's animal or vegetal clue, but we do have some plants that can give resin that can be used for ensuring the fitting of lithic elements on the wood. So it's another one possible use. And of course, a use-wear analysis of lithic tools have shown that the treating of leathers was taking place at the sites. And in this case, we could address the question and the hypothesis whether Pistacia or even oak galls were used for leather tanning, as is still the case in traditional populations. From the various taxa, such as pistachio, hawthorn, or oak, we can also extract dyes that can be useful for textile dyeing. And here we also have one photo showing the use of dye extracted from Pistacea lenticus leaves, still used today for pottery decoration in Tunisia. Of course, in this period, we don't have pottery, but still, the colorants could be extracted from these plants that could be used for decoration. And to conclude and sum up, this presentation shows that during the pre-pottery Neolithic, the inhabitants of these sites were exploiting a variety of local resources. Of course, they were exploiting all these domestic and cultivated plants, but they were also gathering wild plants that they could find around the sites. The archaeobotanical remains, of course, they do give us information about the past environment, but they highlight the importance of these taxa for different everyday life activities that were taking place at the sites. It's very important to take into consideration the contextual analysis when interpreting these results, as well as information coming from other archaeological proxies. And of course, ethnobotanical studies and data coming from the ethnobotanical studies are very important because they can show us what are the possible uses of the plants identified at the sites. Of course, we do not assume that all these uses shown in this presentation were known or practiced by the inhabitants, but ethnobotanical data give us the opportunity to broaden the horizons of our interpretations, and this is exactly the importance and the interest to develop more of this kind of studies. I would like to thank Alexandros Onassis Foundation and Silvia Foundation for funding my doctoral research, the directors of Mission Neolithization and the French Archaeological Mission of Hierokidia for giving me access to the material, my supervisors, Urania Kuka and Margareta Tenberg, and of course, all the people who have contributed to this study. And of course, thank you for your attention.
Thank you very much, Maria. Very interesting stuff. We will have some questions later, so stick around. We move on to the two live presentations here. First one up is Panagiotis Koulouros, who is a PhD candidate at the Cyprus Institute, and he will talk to us about landscape management, environment and cultural associations in Greece and Cyprus during the first millennium BCE. And the evidence comes from wood charcoal.
Okay, hello everyone. So as Angela said, today I will be presenting an overview of my PhD thesis titled Landscape Management, Environment and Cultural Associations in Greece and Cyprus during the first millennium BCE, evidence from wood charcoal, a thesis supervised by Professor Mark Mandela and Dr. Evan Margaritis. Today we'll be going through the sites in Greece and Cyprus that this thesis talks about. A brief mention on the climate and, sorry. Okay. So a brief intro into the climate and vegetation of Greece and Cyprus, and then some research background. Then we'll be focusing on the hypotheses and research questions of this thesis, followed by the methodology, some current results that I have at the moment, and followed by the next steps and some expected results that we expect to find from this study. So the sites that we'll be focusing from Greece are the sites of Corinth, Sikion, Grania, Alos, and Olympos. And from Cyprus, we'll be talking for Tsekezi Gardens, Limassol, Pasili, Dali, Villa Villa, and Kurio. All these sites have been dated dated during the first millennium BCE, with a number of them having multiple phases within this millennium. For example, the sites of Corinth and Sikion have multiple phases throughout this period. In regards to the climate of Greece is characterized by the typical Mediterranean climate, which is highly affected by topographic characteristics. We have several vegetation zones across Greece, with the sites that we're under investigation are mainly dominated by olive trees, pine trees, oak, mastic trees, etc. And in Cyprus, we have an arid Mediterranean climate. Again, it's regional variations due to topographical characteristics. With 6 major vegetation zones, we have the pine forest of Troodos and the Paphos Mountains. We have Karaic rocky areas, coastal areas, wetlands, and some cultivated lands. So some of the research background, during up to the early 2000s, there was a bit of a scarce in archaeobotanical work focusing on the first millennium BCE. However, since then, several studies have been focused on the agricultural practices and the resilience of these past civilizations. Lots of work is concerning chart plan macro remains, which are the ones that are mostly preserved. However, there's a lack of anthropological studies focusing on the first millennium BCE, with only a handful of them focusing on specific sites in Greece, and in Cyprus, unfortunately, don't really have any. So what do we know thus far of the first millennium woodland or how people used wood during the first millennium? Well, the answer is pretty simple, not enough. So hopefully by the end of this, we'll repeat that. So focusing on the thesis, we would like to focus on and answer some questions, mainly to what extent did landscape management, environment, and cultural associations alter woodland composition of both Greek and Cypriot landscapes during the first millennium BCE. And in order to do this, we need to answer some more specific questions. For example, is there any difference in flora composition, both spatially and temporally, between Greece and Cyprus, but also throughout the sites on these two modern-day countries, as well of is there any evidence of cultural, environmental, strategic factors influencing the collection of fuel wood during this period in these societies. So in order to do this, we need to just a brief intro into woods. So we have two types of woods. We have soft woods or gymnosperms, which are mainly characterized by naked seeds, so seeds that are not really protected by a flower or a fruit. And these often include cedars, pines, junipers. And then we have the angiosperms, which are fruit-bearing trees, so trees having a fruit or a flower, such as olive, oaks, pistachia, etc. Now, in order to identify them within the archaeological context, what we do, we analyze the microscopic anatomical features of wood charcoal, and we do this in three distinct planes. We have the transverse section, the radial longitudinal section, which is a cut across the radial, and the tangential longitudinal section. So in order to actually be able to identify wood charcoal, we need to look at all three planes for the characteristics. And of course, softwoods and hardwoods have different anatomical characteristics. For example, here we have in the softwood, we have the trichates, which are responsible, for example, for the conduction of sap and also for structural support. We have rays, trichates, and in some species, we have the resin canals. And for hardwood, again, we have trichates, we have vessels, fibers, and parenchyma cells. All these anatomical features do vary in pattern, size, orientation, and grouping among species, and this is the main way in which we can actually identify different species. So how do we collect the charcoal from the field? First of all, we need the site. So we collect soil samples from the sites. What we do later, we use flotation barrels, flotation devices. So we input the soil into a barrel full of water. The organic material usually floats to the surface, and we collect them. And then we go to the lab, we sort them, sieve them through a 2mm mesh sieve, because anything below 2 millimeters is actually not able to identify because it's too small. And what we do then, after we have collected everything, we break it down. So we want to break it in order to expose a fresh cut. And we do this in all three planes. It is usually made either by hand or using a metrical scalpel, although as you can see here, I'm more into the hand fracturing because it's easier for me. Then we might mount it on microscopy slides using blue tack with the freshly cut side as level as possible so we can have a good representation. And finally, we use a microscope with magnification varying from 10 times to 1,000 times, depending on the anatomical feature that we want to identify. In order to identify, though, looking down the microscope, we use several tools and aids. The most important one is a reference collection, which unfortunately we don't actually have one in the Cyprus Institute, but hopefully by the end of this thesis we will create one. We have several key identification keys focusing on microscopic identifications, anatomical identifications, both from hardwood and softwood. Atlases, either more broad, focusing on European taxa or Mediterranean, or more specific ones like the one in the middle, which is special focus in Cyprus, which is really helpful. And other atlases focusing on wood structure and how it's affected by environment or by human interaction. And finally, online wood databases, which are really helpful as well for the final identification of our fragments. Now, some current results. I'll be talking a bit about the site of Corinth. I have a few results from. Now, the site of Corinth, the specific samples that we'll be talking about is from a cistern field field data from the fourth century BCE up to the first century AD, so early Roman. And what we can see here is a sample from pine. So here we can actually see a resin canal. These are the tracheids that I've been talking about, and here we can actually see the transition between early wood and late wood, so the actual growth rates. Here we can see the rays. This is the red, sorry, this is a transverse section that we talked before. This is a radial section, so we can actually see the rays cutting perpendicular to the tracheids. And finally, the tangential, we can see the actual rays with a resin canal. Again, this is an olive, again, the transverse, radial, and tangential line. You can see the vessels, the rays, and quercus as well. Here we can see the larger vessels, the large rays, which are represented here. So we have two distinct sizes. So we have rays, sorry, that's in the end of the picture, but we have rays quite large, and then we have some smaller ones in size. So it's one of the major identification keys. And these are really some really preliminary results that we have from this specific context. So we can see from the 3rd century BC, we have a major representation of olive and pine trees. We have some pistachio as well, and some other taxa. But what we can actually identify is the fact that it's really dominated by pine and olive trees. And it's really interesting, during the early Roman, we have some grapes as well, so some vitis vinifera, which is quite exciting. Now, from a site in Cyprus, from Cherkezi Gardens, this sample is collected from a room field across various positions across the room. However, here, the only representation that we have is pine. The pinus piece, unfortunately, the fragments were either too small, too fragmented, so we can't actually make a really accurate identification of the sample source. Pinus species. So next steps. Well, definitely more time spent in the lab doing pine identification, going through all the other sites that we mentioned before, and actually doing a contextualization of the assemblages based on the archaeological record and where they're found within the archaeological site, and start to make connections between exploring the dynamic relationship between humans and the environment and how they shape it. Focusing on some expected results, we like to create an extensive anthropological assemblages of the first millennium BCE, both from Greece and Cyprus, and actually see if there's any representation of woodland composition and ecologies and its transition during this period. So if you have any changes during this time period, going from a more diverse woodland composition to maybe less, or vice versa. And finally, to investigate the dynamics and socioeconomic and cultural practices focusing on wood gathering and decision making. Because at the end of the day, the charcoal that we find within the site, it's a decision made by these past societies to go out and collect wood. So it's always important to analyze that. And this can be done through various methodologies. For example, dendrological examination of harvesting intensity. So are they harvesting larger woods or smaller woods? Any dead or weather wood, and thus create some woodland management practices and tie this everything together. So thank you all for your attention. And
thank you very much, Panagiotis. And now the last presentation of this session. It's again about our good friends, the plants, by Kyriakis Tsirtsi. I see here PhD candidate, but is that still your official status? You've just finished. So congratulations again, everyone. Team of the Cyprus Institute, who will talk to us again about archaeobotany, the key proxy for tracing daily life, the case of Sikion. The floor is yours.
Hello, thank you for the warm introduction. And first of all, I would like to thank the organizing committee for having me here today. And as you may assume, today's presentation is closely linked to
No, sorry.
Okay. To my PhD thesis. So in the following 15 minutes, I will present the principal objective results and the conclusions in an attempt to stress the significance of archaeobotany as a key proxy for tracing daily life. So my PhD project entitled Agriculture and Domestic Practices in Classical Scythian Evidence from the Botanical Remains in Vegetarian Pots was funded by the Kasberg Foundation in the form of a 3-year scholarship. And it was undertaken as well as all know, at STARC in South Institute. The botanical material included in this study derives from a project named Old Sicyon, which is a collaboration between the National Museum of Denmark in Copenhagen and the Forensic Activities of Corinth in the Peloponnese. And it was conducted from 2015 to 2019, directed by Dr. Konstantinos Kisas and Silke Mutter Frederiksen for the Danish side. The material was analyzed in STARC, in Sepsis, and my main supervisor was Dr. Margaritis. So classical archaeology has been widely criticized for the lack of integration of organic remains, key in the reconstruction of ancient economy, with the rest of the material culture when interpreting excavation results. This study, therefore, aims to fill this important gap in understanding the economy of the classical and early Hellenistic period Aegean, and it employs several methodological proxies, as you will see soon, applied to the research and excavation project at the site of Sicyon. It offers the first detailed evidence for the agricultural practices and land use of a classical site in Greece, and specifically in the Peloponnese, introducing the study of organic remains as a key component of the project methodology. The main areas of focus of this PhD are defined by the macrobotanical and microbotanical analysis, which are aiming to specify the range of cultivated wild plants and determine which species were predominant in this region in the late classical early Hellenistic period, define crop processing procedures and husbandry regimes, reconstruct crop storage and cooking practices, detect indoor and outdoor activities, human activities by exploring the spatial distribution of botanical remains site, and estimate the extent to which inhabitants were producing for their own substance or for exchange. So moving to Sicyon. Sicyon is part of Corinthia, which is placed in the northeastern Peloponnese. The research area is part of the Corinthian Gulf complex, one of the most active seismic zones in the Eastern Mediterranean. They are expecting a huge earthquake in the following 5 years, so let's see what's going to happen. The research there was focused in Sicyon, and the Sicyon has a climate which is semi-arid, with alterations from subhumid to arid throughout the year. So Sicyon is conventionally divided into the plateau and the plain. The plain, which is closer to the Corinthian Gulf and its shore, is defined by 2 rivers serving as physical boundaries of the plain. Excavations have shown that the classical city of Sicyon was located in the area where the plain is, thus the plateau was occupied from the Hellenistic period onwards. Apart from the effort of antiquities, 2 archaeological missions have been working in the region. The Danish Old Sicyon project, which focused on the plain, and the other project of the University of Thessaly, which focuses on the plateau. No pollen analysis has thus far been conducted, focusing solely in the region of Sicyon. However, useful information for the reconstruction of vegetation and the detection of human activities and land use in the area is provided by a number of studies conducted in relatively close proximity to Sicyon. So the methodology used for this study was, of course, a detailed sampling strategy on site. So I participated in all the field campaigns. Then by the use of the flotation machine that Panagiotis mentioned earlier, we managed to recover and retrieve the botanical material, the macrobotanical material actually, and approximately 680 samples were processed. In total, 13 trenches were excavated. And during the exploitation, we divide each sediment sample into different samples. The one is called light fraction, and in there we can find the macrobotanical material. And the other one is called heavy residue, which we use to also scan and pick every single artifact. So apart from the plant remains, we might find olive stones, for example. We may find also pottery fragments, tiny metal objects, and so on. So I managed to scan only 1/3 of the samples because of COVID restrictions. And yeah, the light fraction was transferred to StarC after the relevant permits were issued. So methodology. We do have a reference collection. I'm sorry, we do have a reference collection of plant remains in StarC. So yeah, I had access to the reference collection. I had access to atlases, and I was also able to use a stereo microscope, but also I used an SEM scan electron microscope and a HIROX and a digital microscope. And through all these analysis, I went through and analyzed more the material, the data that I collected, and also I had the chance to play a bit with statistics. But yeah, I'm not going to discuss that now. Yeah, so let's focus on the archaeobotanical data. As already mentioned, in total 13 trenches were opened in 9 different fields placed in the valley. During the excavation campaigns, various structures such as burials, parts of monumental buildings, ancient roads and channels came to light. Archaeobotanical samples were collected from nearly all the cortex excavated. Given the time limits in the following slides, just 2 trenches with rich assemblages will be discussed. In trench 9A, where several layers of floors and parts of walls were unearthed, all dated to the second half of the 4th century BC, the archaeobotanical assemblages included fragments with barley to be the predominant one in terms of the cereal crops. Vetch was the dominant pulse, however, in very low quantities. Olive is present in all assemblages in blue. A grape is also present, whereas seeds of wheat, white flour are present only in few contexts. In trench 3A, which was located in field 3, the ancient remains revealed suggest that the area was used for a broad time span from the Archaic to the Classical and Hellenistic period. During the Archaic period, it served as a funerary area, as 3 graves were unearthed. Beyond the Archaic remains, a partially subterranean rectangular room, room 1, came to light, part of a larger building complex. The richest context excavated in the room 1 show that olive is abundant. Also that mainly barley was present. Vetch P, which represented the pulse category apart from olive, grape was also present. Pomegranate was also tasted. Among nuts, almond was identified, and wild wheat flora was present in most of the contexts. Given that olive's presence was strong and that complete olive stones were found in the assemblage, it was decided to apply geometric morphometric analysis. For that, I was able to analyze not only the complete olive stones found at the plain, but also some complete olive stones from the plateau, which are dated to the Roman period. And I would like to thank here the director of this project, Professor Lollos. The olive stones analyzed derive from various contexts excavated in the plain and from contexts related to kilns and pottery workshops from the plateau. And the latter are dated to the 1st and 2nd century AD. The results of the morphometric and statistical analysis applied on the olive stones show that the cultivation of several types of olive trees was attested in the area of Sikkim. We have a continuity in the use of olive varieties. Olive cultivation during the classical period is based on several morphotypes, whereas the focus of one basic morphotype during the Roman period may indicate a more specialized olive culture in the region, based on fewer varieties, and presence of roundish olives of wild population reflect the use of wild olives in the ecosystem of the region. During the study of the botanical assemblage from Sicyon, lumps of organic material, acellular masses, were observed. So the following slide focuses on this material and its further study under the scanning electron microscope that we are to have in the institute. So organic masses are lumps with no prominent morphological characteristics, which could not be further identified under the external microscope, were further analyzed by using first the HEROX, the digital microscope, from which we created, let's say, a map of the sample, and then we focused on specific parts of the sample by using the scanning electron microscope. So I will briefly present you just one sample analyzed. So the SC sample is on the left, and after the SCM analysis, we got these three photos, and actually we got the first photo on the left, and the other two photos are the photos we got from experimental work we did in Cyprus Institute. So the two photos on the right and on the bottom represent a fig fragment, a dried fig fragment, which we burned in the institute. So we do observe similarities with our ancient sample, and we suggest that this fragment comes from a fig-based foodstuff. So moving now to starch granule analysis and the micro-botanical remains. This study is the first in which starch granules embedded in pottery dated to the classical early Hellenistic period in the Aegean. The innovative character of this study of results from Sicyon lies in the fact that the analysis of starch granules has never thus far been integrated as a proxy for gaining a better understanding of culinary and storage practice in the first millennium Aegean, which complements the results from the macrobotanical remains. The selected samples from Sicyon derive from various contexts connected with domestic, funerary, workshop, or industrial and ritual activities, covering a wide range of human activities related to storage, preparation, and consumption of foodstuffs. Most of the potteries originate from types of vessels which are connected to cooking, serving, or storage and transport purposes. A total of 60 ceramic sets were sampled for this analysis. But a total of 17 starch granules were encountered, classified the following morphotypes of wheat, like wheat or barley-like starch granules, millet-like starch granules, and tuber underground storage organs starch granules. Although the starch granules found were scarce, it was of interest that tubers were observed during the starch granule analysis, were an additional information that we got because we didn't observe any tubers in the macrobotanical material. So this was a very interesting result. Plus, starch granules were perfect not only in the cooking pots, which was something that we were expecting, but we observed the starch granules also in fibers. So we opened a discussion about the function of fibers. And conclusions. The botanical data from Sicyon suggests similarities with other domestic and urban sites dated to the classical early Hellenistic Sicyon. The agrarian character of Sicyon's economy allowed the cultivation of cereal and pulse crops and the exploitation of fruits and nuts. Sicyon's occupants had access to a little of everything, which in turn allowed them a secure annual subsistence. So, thank you very much for your attention.
As a chair of a session, I couldn't have had an easier job. Everybody sticks to the time. So we have the full time to ask questions. I have plenty of questions for everybody, but before I exploit my position here, I open for questions to the audience. You can, I will leave it free, not follow the order here. You can raise your hand and ask a question and then tell us where it's directed. So any of the presentation, if you have a question, I'll get going until you warm up. I'll ask Ismail, are you there? Are you still here?
Yes. Yes, of course.
I wanted to ask about these shifts. I hope I'm using the right terms because I'm not too familiar with that. But I'm referring to, for example, the example you showed us with the sugar, I think, that one of the bars was obviously shifted in relation to the other bars or spikes. And I wanted to ask if these shifts are consistent within the same type.
Yes, yes. So this shift is a shift in the mass of the peptide or the whole protein, because you're adding an extra molecule, and it's consistent always. The same modification gives the same shift, and that's the power of this analysis I presented, because then once you have the shift, you can go to a database and see, oh, so it was a sugar that was added, or it was that this amino acid was oxidated or whatever. So it is consistent.
So once you identify a specific type of shift, then it could go into your database of possible shifts, and then it's something that you build on, and then it becomes stronger and stronger in a way.
Yes, yes, exactly.
Okay.
Exactly.
Any problems of equifinality? Have you noticed anything that due to the shift, it could become identical to something else?
Yeah, that's a very good question. For example, it happens in for the identification of milk protein that can be from either sheep, goat, or sheep, goat, or cow. There's a modification in one amino acid that actually gives that peptide the same mass as the peptide from another species. So sometimes we don't know if it's a modification that's happening, or if it's that the peptide is coming from cow's milk, from sheep's milk, or goat's milk. So equifinality is actually a big problem here. And there's also a lot of times that peptides cannot be uniquely assigned to a protein. So this is something that's actively being worked on.
It's our biggest enemy in archaeology, no matter the material, equifinality, many different things.
Exactly, can give the same result. Yeah.
Yes. Thank you, Ismail. If anybody else has another question later for Ismail, go ahead. Kyriaki? Come here. Yes, it's better because they can hear you through the mic.
Hi, Ismail. Thank you. I would like to ask you how many samples are sufficient to select during the sampling in order to, let's say, gain the information that we want to reach.
Yes, so it depends on what you're looking for. It also depends on the type of material that you have. Sometimes you're just limited to the amount of samples from where you would expect to find something. For example, if you have a lot of samples and they were all washed, then you probably don't have anything to pick. But if you have samples that have visual, like you can see organic residue, or that have calcareous incrustation, then you can start selecting this. And it also depends it depends a lot on your question and what you're looking for. You can do a more extensive sampling or more focused, but it also depends on the type of samples that you have.
Okay, thank you.
Okay. I have a question for Maria Rusu. Can you hear us, Maria, still?
Yes.
Does anybody else have for now? Maria? Okay. First of all, I really enjoyed the ethnobotanical part. I believe that is a very strong tool to at least broaden our interpretative options. And actually, I would many of the things you mentioned about that are happening in more traditional societies nowadays, they were happening until very recently in Cyprus as well. For example, the use of oil from the terebinth or trees like that, especially in Paphos district, it's within memory of people like my parents' age, for example, they still remember. And I wanted to ask, besides the idea we have that the possibility of pistacia being used for oil, was there any evidence on the archaeobotanical remains that they were processed for oil, for example, such as crushing them or whatever needs to be done?
Actually, yes, this hypothesis was developed in the framework of my PhD research, and it's actually the project, my postdoctoral project. Previously, archaeobotanists have addressed the hypothesis that when we find endocarp fragments, it might be we can interpret it as one evidence for the extraction of pistacia oil, but this is not still it's not still proved scientifically speaking. So yes, this is something that I want to do in my postdoctoral project, combining ethnobotanical data with an ethnobotanical study in Algeria, Tunisia, and I'm very happy you are saying that you have evidence also from Cyprus, because today is not used, but I can find it in historical texts and in other texts until very recently. So I think I will come back to you about it.
Yes, get in touch.
Yes, I think it's a very plausible hypothesis, and I hope I will have more results to show you in the next few months. My project. Thank you very much.
Also, in some of the ethnozoological work that I have done, I also recorded some plants that people were using. Again, you can find them. Actually, my next question would have been to all the plant people. If you have found any evidence of the plant called, in English, I think it's called boxthorn. I think it's Lycium, the genus. Keep an eye open, for example, for that plant. And because it was one of the plants that it was mentioned to me by many traditional shepherds in Cyprus that was used extensively to create animal corrals. You can make very quickly an enclosure for animals using boxthorn, and then somehow it could get deposited at an archaeological site if it got burned, for example, as charcoal. So that's just one idea to all of the people who look at charcoal and plant remains. Okay, thank you, Maria. Any questions? Yes.
Maria,
yes.
I enjoyed very much the presentation.
Could you please come here so Maria can hear you?
Hi, Maria. I also enjoyed your presentation very much, and also the way you link ethnography to your data set. I just want to warn you about a little thing as a textile archaeologist. What you have in the Neolithic, it's bast fibers, basically, as the main fiber for textile production. You don't have wool, unfortunately, yet. So it is very, very difficult for us, for our viewpoint, to dye bast fibers in general, but especially with vegetable-based dyes. And it is difficult without a mordant, and also with a mordant that I doubt you have, because normally it's metal or alum. So I find it a little bit unlikely that those plants were used for textile dyeing in that period, but leather tanning and these kind of things, for sure, definitely. And yeah, I just wanted to let you know our viewpoint, because it's been a very debated question, but majority of textile archaeologists basically agree on this point. So we see vegetable plants for dyeing wool, basically. Just this. Thank you.
Okay, thank you very much for this comment. It's very useful.
Any questions for Panagiotis? Yes, please. Yes, it's better. So online, I see also a lot of people online. They can unmute and ask if they have questions as well.
So yeah, my question is, I don't have a background in the later parts of the first millennium, so I don't know if any of your archaeological sites in Cyprus was involved somehow in metallurgy and that kind. But you know, it's a facility that had a super gigantic impact on land coverage, and so there's this understanding, there's this kind of storytelling about the very massive impact was in the Roman period. But anyway, since the archaic and the Hellenistic period, we know how much metallurgy and the people doing that, they were impacting over. Speaking about expected results, do you think that your secret pattern, especially its diachronic development, we show something resulting from this, which could go from a wider range of woods or narrowing the range? Any expected pattern in this sense?
Thank you for the question. That's a really good question, actually. Yes, like the intensification of the exploitation of woodland composition will actually have, what's the effect that it's going to have on the woodland composition? It's a really good question, and it's a really hard question to pinpoint at the moment. Hopefully, when correlating not just the wood charcoal, but maybe if we can find some other multi-proxy approaches that we can actually towards focusing towards the answer, that would be a really interesting hypothesis, actually, to see if we have this transition during this period. So it would be something definitely to look for, and hopefully we have something. Yeah.
Since you're here, stay here. Okay. Another question for Panagiotis. I have one. If you can tell us a little bit about any other lines of evidence besides your core data of charcoal that you would like to incorporate.
Yes, so definitely some written sources. We have some written sources that talk about the exploitation of wood and different plants, either for medicinal purposes and stuff like that. So that would be a really helpful additional information to have, but also the use of other either archaeobotanical remains, such as the work that Kirati has done with plant macro remains, or other proxies around this period to link between the different questions. So, for example, when we're talking about the transition of like the environmental composition, if it has any climatic implications, the use of other proxies that have dealt with climatic changes such as precipitation levels and stuff like that, that would be a really good additional information to see if we have any, if they align with the evidence that we have from the charcoal evidence and other stuff. So, and of course, ethnobotanical studies to see how maybe it can change like the practices of different plants. I think we have a question from Maria. Yeah.
Yes.
Yes. Thanks. Thank you, Panagiotis. I have one question about the site you presented in Cyprus, Cherkezi. There you showed that you have only pine, if I remember well. Is it a problem of sampling, preservation? Because usually in the archaeological sites we have several tags and not only one.
Yeah, I think for that specific context, it's unfortunately maybe it's because it's been it has some to do with fire, or maybe I'm collecting the same beam, for example, stuff like that. Unfortunately, I don't really have the information from the excavators about the actual context and what they have actually contextualized the room fill. But from there, I could from the wood charcoal analysis, unfortunately, it was just pine. So that would be a really interesting question for me to have with the archaeologists to see what do they reckon about that specific room, because it's quite surprising actually to have only just one type of wood, and I was really surprised to keep finding pine. So yeah, it's a really good question, and hopefully they have some answers. Thank you.
Thank you. think there is another question for now. You can see. And questions for Kyriaki, either from online or from people here. I'll get the ball rolling. Kyriaki, you mentioned the change in the olive cultivation from, let's say, before in the Roman times. This is a very common question, let's say, in all aspects of life. We see this also in zoology. The improvement of animal husbandry in the Roman period. So besides this hint that you had for olives, was there, do we see another expression of that in other plants?
Not really.
Not really.
Yeah, this was my plan. Yeah, I would expect to find more, but because of taphonomical biases, the preservation of the material was poor, unfortunately. So yeah, I cannot answer that question. I just had the chance to answer that through the geometric fluid analysis, thanks to the olive stones. And were well preserved to be analyzed through that methodology.
Maybe other people were wondering about this. When you mentioned the tubers, that you identified tubers starch, what are the options? Potato, definitely not.
No, like onion type. This,
okay, those two.
Yeah, those or beetroot or something like that.
So tubers include the bulb things
Yeah,
as
yeah,
well,
yeah,
not
yeah.
just
Yeah,
potato,
they are
carrots
the
type.
other storage. Yeah.
Okay. Anything else for Kyriaki? Okay. Session closed then. Thank you all very much. Another applause for all the presenters. And
Ismail has, oh no, just president.
Ismail.
No, just.
No, they are just congratulating. Thank
I was
you.
congratulating everyone.
Thanks. Okay. Who will do the?
I am.
Okay.
Okay, so we have reached the end of the first day of the graduate forum for Mediterranean archaeology. It has been a long day, an exciting day. I promise I won't take much of your time. So as from the organization committee, we would like to extend some thanks in general before we close. So first of all, we would like to thank the University of Cyprus and the Department of History and Archaeology for their support for the forum, and especially Dr. Stella Domestica, who came and started off the forum. We would like also to thank the Archaeological Research Unit here for hosting the event and supporting us, and Dr. Athanasios Vionis for his support from the beginning of this whole thing to the fruition. Finally, we would also like to thank Konstantinos Prastitis for his immense help with the technical things. Anything. Also would like to thank Christa Grigoriou for the support and help from the unit. Alona, who took extra time to help us with everything here and organizing the food and the unit and everything. We would also like to thank, I forgot, and I should have put him first, Professor Bernard Knapp, who came and honored us with his presence and the keynote speech. And we would also like to thank our volunteers who helped us. I'm very nervous, I don't know why. So finally, everyone who was here and everyone who presented, thank you so much for attending the first day. We are not finished yet. We have another day tomorrow. We wait to see you all here at 9 or online for the second day of the graduate forum. So there will be a small reception afterwards for relaxation and discussion of any ideas you want. That was it. Thank you very much.